So today is the first half of chapter 6, little review of what we did earlier in the semester together, and it was all the similar triangle information. So in order for two triangles to be similar, what we talked about is they need to have two pairs of congruent angles. So we can see here, while these are obviously congruent, they're both 90. The two that are left over we see aren't congruent, but if we understand that this is all 180 inside, this angle here would have to be 70, so those would all add up to be an overall degree measure of 180. This angle would have to be a 20, so that when these all add up, they also add up to 180. We can see all three angles are congruent, so we would have what are called similar triangles, which means all of their sides are proportional to each other. So if you can kind of keep in mind what that meant here, we have two angles that are congruent here. This angle and this angle are marked. And then we have what we call vertical angles here, directly across from each other. We know those are congruent. So these are similar triangles. So what we would then do is set up, we did a lot of proportions back during that time because of that idea that our sides are proportional to each other. So what we would do is if I went from this marked angle to the vertical angle, that's side X in this triangle. And if I go from the marked angle to the vertical angle over here, that is 8 in that triangle. They are proportional to each other. So in this one, I went from the big triangle to the little triangle. So in much the same way, then I would have to take this side of 10 and compare it to its side of 6. Once we would have that, we would cross multiply to solve this. So 6x would equal 80. X would equal 13 and 1/3, 13.3 repeating. Okay, so that's what we were doing with these. 22, same thing. You have the small triangle here, call that triangle 1. The big triangle here is triangle number 2. We can see that this X that we're looking for is in triangle number 2. So if I took that big one and I compare it to its corresponding side of 15, that gives us one part of the proportion we're going to be setting up. And then since we went from triangle 2 to triangle 1, or from the big one to the small one, then I would want to go from the big one. This one is 40, and its corresponding side is here of 25. Same process, you're going to crisscross, you're going to multiply those. So we would get 25x equals 600. You would then divide by your 25, and then x would equal 24. Once we know this is 24, we could have done it anyway, but we want to find y also. So I'm going to go for y. I'm going to go y, compare that to its corresponding side of 24. And then now we have a couple of corresponding sides to compare. I'm going to do 15 and compare it to its corresponding side of 24. We can crisscross, multiply, so 24y would equal 360. Divide by your 24, and then y would equal 15. All right, so that's what we did with our similar triangles. We then dealt with these, but it's pretty much the same idea in terms of their triangles being similar. We have this small triangle, and then we have the overall bigger triangle. And then we would just set up a proportion for that. So if, let's see here, actually there's a couple different routes we could take. Let's deal with the similar triangles first. Where I could take, let's do the corresponding sides of the small one. So I'm going to take this 10 and then look at its corresponding big side is this big side here. That's going to be 14. Then we come over here. I'm going to find the x right now. The bottom of the little one is 12. The bottom of the big one is this y here. So we can solve that for y. All right, so 10y would equal 168. Divide by 10, and we should get 16.8. So now we know this is 16.8. We would have to do it with that. We could also then do the same thing for your x. Take this big side here or I'm sorry, let's do the small side first. So the 10 divided by the big side over here, which is the 14. And then on this side, take the 15, that's the small right-hand side, or that's the right-hand side of the small triangle of 15. And then we would want the big right-hand side of this triangle, and the big right-hand side would be the sum of 15 plus x. Then to solve this, we would do 10 times 15 plus x equals the 14 times a 15, which, 14 times 15, which is going to be 210. And then we just solve this equation. We would distribute, so 150 plus 10x. Subtract your 150 from the 110 or 210. Should give you 60, divide by 10, and then we should get our x value to equal 6. Now, there is a shortcut with this one that you would want to use for the rest of these, where as long as we have these two triangles that are similar, we could have just done 10 over 4, so 10 over 4, and set that equal to 15 over x. It will work like that for these types of problems. You would still get 10x equals 60. Divide by 10, you would still get this x value to be a 6 like we did at the bottom. This is safer because this works for all of them. Setting up the proportion you would have to do for the base, but for the sides we could use the little shortcut here. Okay. All right, 4 I will leave you just so there's something you got to do sort of on your own a little bit to get some credit, but it's the same process that we would have done in number 3 if you need a reference. A lot of these, again, are similar, so we're going to go through some of these, and then a lot of these I'll leave you. And again, this will become an extra credit opportunity if you finish it, submit it, and it looks pretty competent. So with this, pretty much the same idea. This angle is congruent to this angle because they're vertical angles, and then this angle and that angle are congruent. So we have similar triangles. I'm going to go from the marked angle single tick to the double tick. That side is x, and the smaller triangle single to double is the 10. And then we would go, since I went the triangle 1 here to triangle 2, the big one to the little one, I'm going to use the big side in the numerator for the second fraction, and its corresponding side is 16 in the other. So from there, we crisscross multiply 16 in the x, 10 times 40, 400, and then we would divide 400 by your 16, and that should give you 25. 6, pretty straightforward, just know, like, make sure we're doing the corresponding sides. So when we have an x and a y, we need to make sure we have, let's say we'll do x. So x goes from the double tick side to the one that's not marked. So if we go to the other side, the double tick to the non-marked angle is this side right here. That was 8. The second fraction, then you better make sure that we know the top and the bottom. So the way we know that one is that's the side in between the two marked angles, the 1 mark to the 2 marks. If we come over here, between the 1 mark and the 2 mark, we also know that one to be 12. So we went from this one to this one. We went in this direction, so that means the 15 has to go on top. The 12 goes into your denominator. We can then solve that. If we want to find y, let me erase these then. So let's say we go through the process and we want to figure out what y is. So now let me go here. So the 1 arc to no arcs, and I'm now going to go this one first, this one second. I'm going to go from this side here where we have the 1 arc to the no marks, and that would be over here 20. So I would have y over 20. And then since I'm now going in this direction, I'm going to use the 12, and its corresponding side was the 15. And then we can solve that equation. Okay, so crisscross, solve those, we should be good. All right, 17, we can do 8 I'm sorry, 7. We've had a few of those. You can do those if you like. I'm pretty sure you can look back at number 3 to get you through that problem. Number 8 is a little trickier. We could do 12 over 4 equals x over y. It just doesn't do us any good because we can't solve for either one of those. So we wouldn't just be able to use that shortcut. So what we're going to do is we're going to go 12, the small length, and then think about what the overall length here is. That would be 16. And then on the other side, here's the small length of x, and we're going to compare that to the overall length on the right-hand side, which would be 40. All right, so now this one, as we solve it, you're going to crisscross. So the 12 times the 40 is what, 480, and then the 16 times x is 16x. Divide by your 16. Just make sure here, should be 30. Yes. And then once we know that this is 30, if the whole thing is 40, we would know that y would have to be a 10. All right. So that's how you can do those. 9 and 10, kind of more of the same. Just, being able to kind of go through this, figure this one out. 9, I guess, is a little different. So let's do 9. Here's our 2 triangles. We have this smaller triangle here. And then we have the overall big triangle. So if we look, here's the small side, or the left, or the top side, I guess, of the small triangle. And then if you think about what is the top side of this big triangle, this whole length would be 5. And then what we would want to compare is, since I went small to large, the small side that we know is 8. And then its corresponding big side that we're trying to find is this one down here. And we know that that is x. Crisscross, multiply, solve that, should be set. Okay, same thing here, just a little different version. If you remember, this tells us that we're similar. They are telling us these are similar triangles. So it's going to be pretty much the same process, just knowing what are our corresponding sides, setting up the correct proportion based upon the graph, solving that proportion. So we'll do one of these. Remember, the way these are written are telling us our corresponding sides. So angle K is here. That would have to be congruent to K in the other triangle. Angle L here, so I'll double tick this, has to be congruent to the second variable in the second triangle. So these guys are congruent. And then lastly, angle M. So here's angle M. Do this with 3 tick marks. Has to be congruent to angle U down here. And then we can now pretty easily set up a proportion, hopefully. So since we want this value here, so let's change this to an x. That's from the 3rd tick mark, and we're going to the 1st tick mark. So in the other triangle, you got to go from the 3rd tick mark here to the 1st or single tick mark here. So that's x over 8. Here we're going from the 2 ticks to the single tick. That's our 21. So the next place in the other triangle we go from the 2 ticks to the single tick is here. That is 7. All right. Crisscross, solve. All right. Go through all that. Should be good. These are pretty much the same. If we go down to 15, this one might be a little trickier. So we'll talk about this one, where let's call this our x. So the way I would set this up is, let's take the 12. Let's compare it to the x here. But in order to do that, what we would want is, on the 12 side, here's the overall length. That's 28. And then we would want to compare that to the overall length on this one. And that's why you were given this to be a 49. That's that. And then just, more of the same, more little practice here until you get to number 19 and number 20. So midpoint, the way we found our midpoint, we really just kind of average together both the x and the y. So here's the general midpoint formula. You want to add up the x's, divide by 2, and then add up the y coordinates and divide by 2. So the midpoint of this one, we're going to add up the x values. So here's an x, here's an x. So we do a -5 plus a -6. Divide that by 2. Then we want to add up the y values. So here's a y, there's a y. We're going to add those up, and we're going to divide that by 2. Basically find the middle of those two. Whatever that thing gives us should be our midpoint. So this would be a -11 over 2. This would give you 20 over 2. So our midpoint would be a -5.5. You could leave this fraction if you wanted, but if we do a decimal, -5.5, and then the y coordinate would be a 10. Okay. So same thing here. If you wanted to, you're basically just taking this formula here, doing the exact same thing in number 20. If it's 21 where you have a graph, you could do the same thing. So we could call this the point 1, 1. We could call this the point 5, 3. So with those 2 points, you can then just do the same formula that we did in number 19 and what you would have done in number 20. This is also one, though, where if we understand if I'm going to go from this point to this point, we would have gone up 2 and then right 1, 2, 3, 4. So my overall slope is up to right 4. Well, if we want to go into the middle, anytime you want to go into the middle of something, you're basically cutting that in half. So what we could say that we're going to do is divide this here by each of these by a 2. So that would just be a 1 over a 2. So if we now do that, let's go up 1 and go right 2. Notice how that takes us right to the middle of that line segment. And then we can just label that point. All right, that point ended up at the point 3, 2. That has to be our midpoint. Okay? All right, so with that, we should have over half of these done probably. You can go through, if you want to get a little extra credit, some extra points here, submit that to me, and then have yourselves a good week, and we'll see you next week.